Hello, geometry students. This is Mrs. Raposa. This is your 4.1 Hybrid Out lesson, and we are going to classify triangles and find measures of angles. Hopefully you have a copy of these notes already. If you don't, you can just take notes on a plain piece of paper. Please copy down the definitions and the examples as I do them in the notes. And as always, you can pause the video and replay anything that you didn't catch the first time. And you can always contact your teacher if you have a question on any of these in the video. Let's get started. For example 1, we're asked to classify each triangle based on its side lengths. And since we're asked to classify based on side lengths, I want to use either the word scalene, isosceles, or equilateral. When we get to example 2, we're asked to classify the triangles based on angle measures. And in that case, I would answer with one of these 4 words: acute, right, obtuse, or equiangular. Let's look back at example 1. The first triangle has markings to indicate that all 3 sides are the same length. Since all sides are congruent, that's considered an equilateral triangle, a word you're already familiar with. The second triangle has 2 sides only marked congruent, so we call that an isosceles triangle because it has 2 sides that are congruent. And this third triangle, we have no sides congruent, so we call that a scalene triangle, no congruent sides. Some definitions of isosceles tell us that an isosceles triangle is a triangle with at least 2 congruent sides. If you use that definition, then this could be considered an isosceles triangle because at least 2 sides are congruent. However, I wouldn't classify it as isosceles because all 3 sides are congruent, so the word equilateral is a better classification than isosceles. Something you should know about isosceles triangles, especially before doing the classwork that goes with this assignment, is that isosceles triangles have 2 sides congruent, which means they also have 2 angles that are congruent. Across from those 2 congruent sides are going to be 2 congruent angles. So we call these the base angles on isosceles triangles, something you'll learn later. But for right now, on your notes, I would mark that the 2 angles across from those 2 sides have to be congruent. Okay, before we do example 2, let's use the Triangle Sum Theorem to find the measures of angle F and C first. So we'll do example 3 before we do example 2. You may know from a previous course that the 3 interior angles in a triangle have to add up to 180 degrees. So you can go ahead and fill that in your notes. So the sum of all 3 interior angles has to add up to 180 degrees in a triangle, as long as the triangle is a 2-dimensional triangle. So this theorem is only true if it is a flat triangle. So on a globe, it's a little different story. But for right now, we're just going to take a look at the Triangle Sum Theorem on 2-dimensional triangles. So for example 3a, let's find the measure of angle F in triangle FGH. Well, I know that all 3 interior angles have to add up to 180 degrees. So the measure of angle F plus the measure of angle G plus the measure of angle H equals 180 degrees. And I already know that the measure of angle G is 68 degrees and the measure of angle H is 74 degrees. So I will substitute 68 degrees in for the measure of angle G and 74 degrees in for the measure of angle H. My next step is to combine my like terms. 68 plus 74 is 142. So the measure of angle F plus 142 degrees is 180 degrees. And next I'm going to subtract 142 from each side of the equation, which will leave me that the measure of angle F is 38 degrees. And I'm going to go ahead and mark that right in the triangle, that angle F is a 38-degree angle. Okay, so now we're going to find the measure of angle C in triangle ABC using the Triangle Sum Theorem. Well, I already know that the sum of all those angles inside that triangle have to add up to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Well, I already know that the measure of angle A is 28 degrees and the measure of angle B is 130 degrees. So I'm going to substitute in 28 for the measure of angle A and 130 for the measure of angle B. So 28 degrees plus 130 degrees plus the measure of angle C equals 180 degrees. And we can combine our like terms because 28 and 130 degrees adds up to 158 degrees. So now I'm just going to subtract 158 degrees from each side of the equation, and that will give me that the measure of angle C is 180 degrees minus 158 degrees, which is a 22-degree angle. So the measure of angle C is 22 degrees. Okay, now we have enough information to do example 2. This first triangle, I notice that there is a right angle in it, so we classify that as a right triangle because it has one right angle. This second triangle has all three angles marked congruent, so you already know that vocabulary word. That is called an equiangular triangle because all of the angles are congruent. This third triangle has three interior angles that are all less than 90 degrees. So we're going to classify that triangle as an acute triangle because all of the interior angles are acute angles, less than 90 degrees. This fourth triangle has two angles that are acute angles, but this angle is an obtuse angle. An obtuse angle is an angle that measures between 90 and 180 degrees. So if there is an obtuse interior angle in a triangle, then we call that triangle an obtuse triangle because one of the angles is obtuse. For example 4, I am given variable expressions for the measure of angles A and B, and I'm told that the measure of angle C is 60 degrees, and I need to find the measure of angle A and the measure of angle B in this triangle. And first, to do that, I need to solve for x. So I know that all three angles, A, B, and C, have to add up to 180. So I make substitutions. 5x plus 4 added to 9x minus 10 degrees added to 60 degrees equals 180. If I'm given the three interior angle measures, whether in numbers or variable expressions, I add all of those numbers or variable expressions together and set it equal to 180. And the next step to do is to solve the equation for x. So let's first combine our like terms on the left side. I have 5x's and 9x's, both on the same side of the equation, which is 14x. And when you combine the constant terms, positive 4, negative 10, and positive 60, you end up with 54. So we really have 14x plus 54 is equal to 180. Next, I will subtract 54 from each side of the equation to give me that 14x is equal to 126. So if 14x is equal to 126, divide each side of the equation by 14, and that will give me that x is equal to 9. So now I just need to substitute 9 in for x into those two variable expressions to find the angle measures. So for the measure of angle A, 5x plus 4 becomes 5 times 9 plus 4, which is 45 plus 4, which is 49 degrees. So the measure of angle A is a 49-degree angle. So now let's take a look at finding the measure of angle B. The measure of angle B is 9x minus 10 degrees. Substituting 9 in for x, we get the measure of angle B is 9 times 9 minus 10, which is 81 minus 10, which is 71 degrees. So the measure of angle B is 71 degrees. And I always like to double check my work. So I'll add those three angle measures together to make sure they add up to 180. And 49 plus 71 plus 60 does add up to 180. So that is correct. As we get into the part of the notes where we discuss the exterior angle theorem, I'm going to let you know that anything that is written in red in this part here, you should copy into your notes. Anything that I write here in blue later, you do not need to copy into your notes. If you need to stop the video now and write this down, you can go ahead and do it. It's in red. It should be copied into your notes. Before we talk about the exterior angle theorem, we first need to define what we mean by exterior angles. Of course, exterior angles are outside of the triangle, where interior angles are inside the triangle. Exterior angles to polygons are formed when we extend one side of the polygon, or extend one side of the triangle in this case. This exterior angle and its adjacent interior angle next to it form a linear pair together, so they are supplementary. That means that the measure of angle 1 plus the measure of angle 2 is 180 degrees. Again, this is in blue. You don't need to copy it into your notes. Using the triangle sum theorem, I also know that these three angles also add up to 180 degrees. That means that the sum of these two angles is equal to the sum of these three angles combined, because both sums equal 180. If I subtract the measure of angle 1 from each side of this equation, I'm left with just that the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And that's really the exterior angle theorem. It tells us that the measure of an exterior angle is equal to the sum of the two interior angles that are not next to it. So in this case, exterior angle 1 will equal the sum of these two interior angles, A and B. And that is the exterior angle theorem, that the measure of the exterior angle equals the sum of the two interior angles not next to it. And we'll use that in example 5 to solve for the measure of angle Q and the measure of exterior angle SPQ. Again, this is written in red, so that should be written in your notes along with this. For example 5, angle SPQ is an exterior angle of this triangle formed when we extended side RP. Using the exterior angle theorem, I know that the measure of this exterior angle, 7x degrees, will equal the sum of the two interior angles of the triangle not adjacent to it. And we obtain this equation, 7x degrees equals 2x plus 7 degrees plus 43 degrees. Combining like terms on the right side, 7 plus 43 is 50, and I get 7x equals 2x plus 50. When we subtract 2x from each side of the equation, we get the equation 5x equals 50. Dividing each side by 5, we get that x equals 10. And if x equals 10, then I know the measure of angle SPQ is going to be 7 times 10 degrees, or 70 degrees. And the measure of angle Q will be 2 times 10 plus 7 degrees, or 27 degrees. I always like to check my work. If that is a 70-degree angle, then because these two angles right here, the exterior and the interior, are a linear pair, this one will be 180 minus 70, or 110 degrees. And that means that the sum of the three interior angles will be 110 plus 27 degrees plus 43 degrees, and that does add up to 180. So it checks out.